Hello students, this is Zelastic Physics. Today I will be doing potential difference between 2 points using Kirchhoff's rules. Kirchhoff's first rule is KCL, or the junction rule, in which sum of the current flowing in a junction is 0. And the second rule, that is loop rule or KVL, Kirchhoff voltage rule or voltage law, is based on the conservation of energy. The first rule, that is KCL or the junction rule, is based on conservation of charge, and the second rule is KVL, it's based on the conservation of energy. So it says in a closed loop, sum of the voltage gain or voltage loss is 0. So I can write like this, or simply, now I'm following the sign convention. Just follow the board. So if a current I flows through resistance R, so if I go this way, so it is IR. So if I follow the reverse way, it is minus IR. And for the EMF, for this is minus. So these are the sign conventions. I'll be following it. You can follow any other sign convention, but for a particular sum, the particular sign convention should be true for all steps. You cannot change the sign convention in the middle. For example, if you are doing a sum, you have to follow a particular sign convention. If you are following mine, so for the whole sum you have to follow this. Now I am doing certain numericals to explain this, to find the voltage drop or the potential difference. Let me do this. So first sum, I am drawing a circuit. This is point 1, this is point 2. This is 2 volts there. And 1 ohm resistance. Now so I find V1 minus V2. That means I am going this way. See. So I have to do that. So I am going this way. See my path. So this is the direction showing by the arrow. So as no current flows, my I is 0. The circuit is open. So it is minus V2 plus 1 into 0, no current, minus 2 plus V1 is equal to 0. So my V1 minus V2 is equal to 2 volt. Now I am going to the next sum, minus V2. So plus 1 into 0, follow my path, and I'm following this sign convention. So minus 2, because I'm coming this way, plus V1 is equal to 0. So now I'm doing the next sum. Now second circuit is also open. Circuit is open. So I am drawing the circuit. 3 volt. It is 1 ohm potential difference. This is 1 ohm. This EMF is 1 volt, followed by 2 ohm resistance, and this is the point 2 and this point 1. Now we have to find V2 minus V1. So I am going this way. So we have to find V2 minus V1. This has to be followed, and of course we are following the Kirchhoff sign convention. Kirchhoff's rule, following the sign convention, I write minus V1 plus 3, see, plus 1 into 0, because I told you this is an open circuit, no current flows, minus 1 plus 2 into 0, no current flows, 2 into 0, plus V2 is 0. So calculating, I get V2 minus V1, 1 minus 3 is equal to minus 2 volt. So the magnitude matters because potential difference is scalar quantity. So 2 volt, it's minus 2 volt because I am following this direction. So I am going in the reverse way, it would be 2 volt. Now you can copy this down because I am going to the next sum. Sum number 3. Now here your current is 2 ampere, it's given 2 ampere. Now I have to find VBA. That's my question. So I draw the circuit. DC 2 ohm, and remember 2 ampere current is flowing. If I am not mentioning it on the circuit, so take notice of this. This is 4 volt. This is 1 ohm, followed by 6 volt, then 2 ohm resistance comes in the way and it reaches the point B. So this is the circuit. So you have to find VBA. So that means it is VB minus VA. So VB minus VA. So I am following this path. See, and remember 2 ampere current is flowing. So following this I get minus VA plus 2 into 2, 4. So 2 multiplied by 2 is 4. Because 2 ampere is going. So 2 multiplied by 2, 4 ampere. 4 volt here. Plus 4 from the EMF. Plus 2 here, 1 into 2. Minus 6. And again 2 into 2, 4. Plus VB. Because current is going this way. So following the sign convention. So my VB minus VA comes, if you calculate it, 4 plus 4 plus 2, 10. 10 plus 4 is 14. 14 minus 6 is 8. So it should be minus 8 over here. Same thing, VB minus VA is minus 8 volt. So I did 3 sums and now I am going to the fourth one. The fourth one is a bit different. take this down. And I'm going to the fourth sum. So for that reason I require some space. So I think you have followed this. You have written this, the sign convention. So I need to clear this space. Sign convention. So this fourth sum, a part of the circuit is given. I'm drawing the circuit first. This is the circuit. Sum number 4. Circuits are very important. Remember, you have to study the circuit carefully before starting the sum. I mean, before starting the calculations and all that. So this A, 4 volt. This is 4 volt. 1 ohm. Now there is a point X is grounded. Remember this. So that potential of X becomes 0. This point X. Now 2 ohm. Then 6 volt. One ohm, and then the point B, then the point B comes. Now, so a part of the circuit is given to you, and the point X is grounded. Now I have to find VA minus VB, the potential difference between the point A and B. It has to be found out. So it is naturally VAB. So this has to be worked out. Now, see. So I am going this way, VA minus VB. So minus VB minus 4 plus 6 So current of 4 ampere is flowing. So this is 4 ampere current is flowing. Remember this. So in that case, minus VB minus 1 into 4, 4 plus 6 minus 8, 4 into 2. Current is flowing this way, and I am going this way from B to A. Minus 4, again minus 4, and then plus VA. This is 0. So I'm calculating and finding it. So your VA minus VB comes 14 volt. Now potential of X is 0. We can see that it is grounded, and it is mentioned also. For finding potential at A, we are finding the potential at A. We will move from X to point A and apply KVL, Kirchhoff's voltage law. So it's grounded, so 0 minus 4 into 1 minus 4 plus VA is equal to 0. So on calculating, I find VA comes 8 volts. So that is the result. So I have done the fourth sum. Now I am going for the fifth one. For that I have to remove this one from the board. So this is number 5. Now look at this circuit. It's a different one. Not very difficult. These are very easy sums. And follow the sign convention and the path you are moving. So, and now A, this is B and this is C. It's 6 volt over here at point A, and I take V over here. So I have calculated this V, the potential at this point. Then 2 volt over here and 1 volt over here. So these are all given. To find V. The potential of points A, B and C is so 2 ohm. It is 2 ohm resistance. This is 4 ohm and this is 1 ohm. The potentials of the points A, B and C are provided. So we have to find the voltage at the junction. That is, we have to get, or we have to find V. Now let us assume that the current in each branch flows towards the junction. That is at this point where V has to be calculated. So potential of A, B and C is more than the junction potential. That is V. Because potential drop will occur as it passes the resistance. So by KCL we know, if we consider this current as I1, this current as I2 and this as I3, so I1 plus I2 plus I3, according to KCL, this is, the sum is 0. So computing this, I am writing over here 6 minus V by 2 plus 2 minus V by 4 V is equal to IR, so I am doing V by R is equal to I. So I1 plus I2 plus 1 minus V by 1 is equal to 0. So if we calculate it, so what is the LCM? 2 and 4? 4. So multiply both sides by 4. So it becomes 2 into 6 minus V plus 2 minus V plus 4 into 1 minus V is equal to 0. It comes. So if you open the bracket, 12 minus 2V plus 2 minus V plus 4 minus V is equal to 0. So to solve, you find minus 7V is equal to minus 18. So your V comes 18 by 7 volt. So that is the curve. So 18 by 7 volt. Hope you have learned this. I have used KCL. So I get I1 plus I2 plus I3 is equal to 0. Now I am doing another sum. Sum number 6 I am doing over here. So I require some space. Sum number 6. So again a part of the circuit is given. So I draw the circuit. This is A. There's another resistance over here. Now this is grounded. Now it's 4 volt. It's a part of the circuit. It's 2 ohm. It's 6 volt. It is 2 ohm. It is 4 volt. So I have to follow KVL. I have to so current I enters through A. So it should be 2 ohm. So I'm going this way in the direction of the current. So by KVL, -4 2i plus 6 plus 2i, current I flows, -4 plus 0, because it's grounded, the point B is grounded, so it's 0, potential is 0 there. So 2 plus 2, 4i is equal to 2. So -8 plus 6. So -2, so 2 goes there. So your I comes 2 by 4 or 0.5 ampere. So that is the value of I. So we have to find the potential difference, and also I've got current over here in this circuit. We have drawn the part of the circuits, and we have calculated the potential difference between 2 points. So hope you have understood the problems that I've done, and I followed Kirchhoff's law in all cases. So thank you very much. If you like this video, kindly like, share and subscribe. Thank you.